Hello everyone, in this video we're going to be solving a cubic equation. At this point you may just want to pause the video and give this problem a try. Okay, so we have x cubed plus x plus 1 cubed plus x plus 2 cubed equals x plus 3 cubed. So on the left hand side we do see a sum of cubes that are basically consecutive, and the right hand side is just continues from where we left off. So you may want to stop and pause about this video first, because we're looking for integer solutions, not necessarily real solutions or rational solutions. Okay, so how do we go about solving the integers? Well, you can just kind of do trial and error here. You can test some values if it works, and then it works. Now you may remember some of the relationships among cubes, like can we add 3 cubes to get another cube? And obviously that's quite possible. There are solutions, but we're especially looking for integer solutions. So it might be helpful to think about any identity or special type of relationship that you may know among the sum of cubes of numbers. Okay, so we can just go ahead and list some of the cubes here, starting with 1 cubed. Let's go ahead and list those cubes. 1 cubed is equal to 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and 7 cubed is 343. And 8 cubed is going to be 512, so on and so forth. Okay, so obviously they're going to grow quickly, but the idea here is we have to take 3 of the consecutive ones and get something nice from there. And if you kind of check out these values, you're going to notice that, for example, if I add the first 3, obviously, they're not going to give me 64, correct? If I add the second third, like the triple, then that sum is not going to give me 125. If you check these, okay, what you're going to notice is that you're going to get what you're looking for. Because what happens is 27 plus 64 is 91. 91 plus 125 is 216. So basically, what we get from here is that 27 plus 64 plus 125 is equal to 216, which means 3 cubed plus 4 cubed plus 5 cubed is equal to 6 cubed. You may or may not have seen this before, this relationship, but this is very common. There are a lot of consecutive powers that you can add to get another power, and this is just one of them. Okay, anyway, so how does this help us? Well, here's the goal. Since we're looking for integer solutions, we're not interested in rationals that are not integers. We're not interested in irrational solutions, so on and so forth. So what I'm going to do is I'm going to look at my equation and then look at this identity, which is definitely true, right? And then I'm going to try to manipulate my equation to reflect that. So how on earth am I gonna be able to use that to my advantage so that the right hand side is equal to 6 cubed, right? So here's what I'm gonna do. Okay, to take advantage of this problem, what I'm gonna do is I'm going to replace x with u plus 3, and you know that I like u substitution, so then I'm gonna be getting something nice. What is that gonna look like? Well, I'm gonna be getting u plus 3 cubed plus u plus 4 cubed plus u plus 5 cubed is equal to u plus 6 cubed. Now, what is the significance of using this x equals u plus 3 as a substitution? The significance is we're going to be getting constant terms from here that are 3 cubed plus 4 cubed plus 5 cubed, which is equal to 6 cubed, and you're going to see what happens in a little bit. So stay tuned. Let's go ahead and simplify this now. I'm going to expand u plus 3 cubed, and I'm going to do it on each one on a different row so that addition is easier and it doesn't take super long. Okay, let's go ahead and start doing that here. So the first one is going to look like u cubed, right? Plus 9u squared plus 27u plus 27. This is the first one. And the u plus 4 quantity cubed is going to be u cubed plus 12u squared plus 48u plus 64. And by the way, I just want to quickly take note here so that you know what I'm talking about here. I'm going to write down the formula for x plus y quantity cubed. For your reference, x plus y cubed is equal to that. And then I'm using that formula right now. Okay, awesome. Let's go ahead and continue with the u plus 5 cubed. That's going to be u cubed plus 15u squared plus 75u plus 125. And as you know, the sum of these three things is going to equal what? Let's go ahead and add those first. That's going to give me 3u cubed plus 36u squared plus 150, because those two add up to 75 as well. Plus, as you know, this is supposed to be 216. And on the right-hand side, I do have u plus 6 quantity cubed. So let's go ahead and write that down here. That's going to be u cubed plus 18u squared plus 108u plus 216. Now, here's where the magic happens. The constant terms are equal. And isn't that beautiful? It's awesome. So what we're going to do is we're actually going to cross them out, all right, from this point on, and continue. Okay, yeah, let's continue with this one. So 216 is going to cancel out. Then if you put everything on the left-hand side, you're going to be getting 2u cubed plus 18u squared. If I subtract 18u squared, 108 subtracted from 150u, you're going to be getting 42 plus 42u. And obviously there's no constant term, so this is equal to 0. Not only that, not only is this a cubic equation, but it's also a very easy equation to solve. Now, how is that possible? Well, we can factor out a 2u. Again, the 2u comes up. U squared plus 9u plus 21. And that is equal to 0. Awesome. Now, remember, we're looking for integer solutions, but let's go ahead and find all the solutions. We can just discard the ones we don't want. So from the first part, we get u equals 0, obviously. And since x is equal to u plus 3, this means that x is equal to 3. And you know that, you knew that because at the beginning, we established that 3 cubed plus 4 cubed plus 5 cubed is equal to 6 cubed. Cool. So we got one integer solution. Let's see if there's any more. So the second part of the equation gives us a quadratic. U squared plus 9u plus 21 is equal to 0. Let's go ahead and explore if this equation has any integer solutions. Is it factorable? So I kind of tend towards the 3 times 7, but oh, we don't have 10u. That would be nice if we did, but unfortunately that's not the case. So what are we going to do? Well, we're going to try the discriminant. Let's check the discriminant, the delta. B squared minus 4ac. And as you know, this is going to equal 81 minus 84, which is negative 3. That means the discriminant is less than 0, which means we don't get any real solutions from here. For real, we don't even have irrational solutions. Okay? So this doesn't really give us anything we want, but this does. So the only integer solution to this cubic equation is x equals 3. I hope you enjoyed the video. Thank you for watching. Please comment, like, and subscribe. And see you in the next video. Bye-bye.